Hey, how's it going? My name's Hari, and I'm going to show you how to build an application using the Eidolon agent framework. And I actually want to start with the end result first, which is an application that's connected to the San Francisco database that can tell me, while communicating in English, how many murders, how many thefts, any crime-related statistic happened during any period from, at least in the case of this application, from 2018 to present. And how this works is when I type in something like how many murders happened in 2021, my user English query goes off to a crime agent that's just a generic agent that's prompted, you're a helpful crime agent, that takes my user query, converts it to SQL, sends it to a SQL agent, which pings the back-end San Francisco database and returns information to me. In 2021, there were 14 murders reported. So, based off of media reports, to me that actually sounds low because all of the news outlets make it sound like San Francisco is crumbling, right? So if I don't particularly trust that, the beauty of using the agent framework is I actually get to test each individual isolated piece of logic in my application. So say I don't trust the LLM GPT conversion, I'm actually going to send a query in SQL directly to the SQL agent that should give me a different result if ChatGPT fumbled the conversion. So what I'm going to do is talk to the SQL agent, select count star as total murders from incident reports, that's my table name, where incident category equals murders and incident year equals 2021. So we're going to fire that off, and if everything in this application is working correctly, I should see that there were 14 murders, which is exactly what I do see. So San Francisco is a little bit safer than everyone makes it out to seem. But we do have a problem with human feces. So why is this useful at all? Well, it's useful because what are people doing today to get this kind of information? Well, it's really difficult to get. And to show you what that looks like, if I go to data.sfgov.org, which is where this data set lives, if I search murders, I get nothing. Pretty sure. Yeah, if I search how many murders, I also get nothing. So I don't even know how I found this data set. I'm sure I was sifting through one of these links here. But then when I actually find the data set, because the search doesn't actually work, then I need to sift through all this information, which either requires complicated filtering logic or a knowledge of SQL, which is why you need data analysts. The beauty of what we're doing over here at Eidolon, or really anyone that's building a generative AI RAG application, is we lower the bar that's needed to communicate to get the desired and necessary information. So what this looks like, because we're going to see this architecture expand and people are going to be doing this across many different data sources, which requires and would be smart to have an isolated agent for each, is we're actually going to see this architecture being used all over the place in every scenario where information is hard to access. And all it looks like is a user query. So Hari user query is sent to any generic agent depending on what your use case is. In this case, it's a crimebot that is prompted as you are a useful crimebot. And then the crimebot, which is GPT enabled, sends the converted logic of my user query into SQL. And the SQL agent hits the SFDB. And finally, the San Francisco database where all the information lives returns the information I need, where GPT delivers it to me in an English readable response that's really clean to see. So this can branch out into vector databases or multiple SQL databases or tables depending on what you need. But the power of what you can do with Eidolon is you can scale this to get as big and as complicated as you need. And once again, if there's any sort of points of failures, just ping each agent that's responsible for each task, and you'll easily be able to find what you need to do to make your application work.